Here in Module 1.1, we're looking at functions and the basic definition of a function, which in your reading you found that a function is a relationship between input values and output values that follows one rule. And that rule is that every input value corresponds to exactly one output value. Another way to think about that is that no input value corresponds to more than one output value. You can't have more than one output for a given input. Let's see how that works through these examples. We're going to see three different ways in examples 1 through 3 here, three different ways of viewing functions and how that definition applies in each case. First of all, we're just given a set of input values and output values here with these ordered pairs. My input values are in these ordered pairs. My input or first component values are A, C, and A. And my output or second component values are B, D, and C. The way I'm going to kind of visualize the relationship here is I'm going to list out all the input values. The input values are just A and C. Those are the only two input values that are listed in these ordered pairs. And the output values, B, D, and C, the second components of my ordered pairs. And I'm going to read the ordered pairs, first of all, A comma B, as an input value of an input value of A corresponds to an output value of B. And in the second ordered pair, C comma D, an input value of C corresponds to an output value of D. And the third ordered pair, A comma C, an input value of A corresponds to an output value of C. And what we note here is that one input value, A, corresponds to more than one output value, B and C. We can't have more than one output for a given input, so this is not a function. Next up, another set of ordered pairs, A comma B, B comma C, and C comma C. Let's list the inputs and outputs again. I see inputs A, B, and C. And then outputs B, C, and C, or just B and C, are my output values. If we match up, we see the first ordered pair has A matched with B, so an input value of A corresponds to an output value of B. Second ordered pair, an input value of B corresponds to an output value of C. And the last ordered pair, C comma C, says that an input value of C corresponds to an output value of C. And what we see then is that every input value corresponds to exactly one output value. That is a function. We might note here that we've got two inputs that correspond to the same output. That's okay. It's okay to have more than one input correspond to the same output. You just can't have one input that corresponds to more than one output. So these two scenarios, these two examples side by side, give a good example of what is a function versus what is not a function. But we usually don't see functions written out as ordered pairs. Usually we see functions either in equation form, as we see in example 2 here, or in example 3 on the next slide we'll see graphs of functions. And so let's continue with our discussion here. Still talking about the definition of a function, and is there only one output value for a given input value? This time we're looking at an equation, 3x squared plus y equals 14. And the idea here then is to think of x as the input variable and y as the output variable. And x as the input variable, x can be anything we want. We can plug whatever value we want in for x. We're not actually going to plug in all the different values of x, but we want to think of x as an input variable, meaning it can be whatever we want it to be. And y is the output, the corresponding output variable. To determine whether there's only one output, only one y value for a given x value, for a given input, the easiest way to do that with equations is solve for the output variable, solve for y. That's not terribly difficult to do in this case. We would just subtract 3x squared on both sides. Subtract 3x squared on both sides, and we've got y equals negative 3x squared and a positive 14. So y equals negative 3x squared plus 14. And just having done that single step and solving for y, I now see that no matter what I plug in for x, this is what y is going to equal. Y is going to equal negative 3 times x squared plus 14. Whatever number value x takes on, this is what y is going to equal. And y is only equal to this one expression. Because y is only equal to this one expression, then that means that we only have one y value, one output value. No matter what x value we plug in, the corresponding y value, there's only one of them. And this is it, negative 3x squared plus 14. That tells me then this is a function. With equations, we say that if you can solve for y, if you can solve for the output uniquely, just get one expression that y is equal to, then you've got one output value for whatever input value you start with, and that is a function. On the other hand, 2x plus y squared equals 6. If we try the same approach, try to solve for y here, I would subtract 2x on both sides, leaving me y squared equals negative 2x plus 6. And then to get y by itself, I need to get rid of that square, so I take the square root on both sides. And then I have to remember the rule that says when I take the square root on both sides of an equation, I end up with plus or minus. Y is equal to plus or minus the square root of negative 2x plus 6. And if you don't remember that rule, then I strongly suggest you go back and read about that in the text, or ask me about that in our virtual class session or in the virtual tutoring lab. We can help with that. But the key here is to see, when I take the square root on both sides, I get plus or minus. Y equals plus or minus the square root of negative 2x plus 6. Then y is equal to two different expressions. Y is equal to the positive square root of negative 2x plus 6, or y is equal to the negative square root of negative 2x plus 6. Plus or minus. We've got two expressions that y is equal to. We've got two things that y can be. We've got two y values for a given x value. Two outputs for a given input. That is not a function. Last but not least, we've got graphs. And in graphical form, we have a test that we can apply to determine if the graph we're looking at, if the curve that we're looking at is a function or not. It's called the vertical line test. And basically what it says is if you can pass a vertical line, I'm going to try to draw a vertical line, probably not going to do too great a job. That's not bad. If you can draw a vertical line that crosses through more than one point on the graph, then we say that it fails the vertical line test. The vertical line test says every vertical line has to pass through no more than 1 point. No more than 1 point. You can't have 2 points on the graph on the same vertical line. And the thought there, the reasoning behind that is, look at the vertical line that I just drew through this graph. That vertical line corresponds to a specific x value, the x value of 2. And the fact that that vertical line passes through more than 1 point on the graph means that there's more than 1 point that corresponds to that x value of 2. There's more than one y value. Specifically, we could even read off the points here. For an x value of 2, for an input of 2, on this particular graph, I see a y value of 0 and a y value of 2. I see two y values for the same x value. A graph that fails the vertical line test and passes, where a vertical line passes through more than one point, that means that there's a single input value that corresponds to more than one output value. Failing the vertical line test means it is not a function. On the other hand, here, no matter what vertical line we draw through this graph, use your imagination to think that these are actually vertical lines that I'm drawing. No matter what vertical line we draw through the graph of this curve, every single one of those vertical lines only passes through a single point. That means that every x value that I can think of here corresponds to only one y value. Only one point for every vertical line means that we have only one output for every input. In that case, we say that the graph passes the vertical line test with only one output for every input. It is a function.